So good morning or good afternoon, depending where you're connecting us from. So welcome to today's session on Digital Africa as part of the Africa Earth Observation Challenge 2015. So this is a masterclass just to introduce you to the Digital Africa platform and see if it will be one of the platforms you wish to use for your challenge. So ideally from August to September, you might have come with some solutions, then October, November, and the final event will be early December. So Digital Africa is powered by partnerships. We are working with partners across the continent, and also this powered by partnership. So we are using Amazon Web Services as the cloud host, and we are using the Open Data Cube technology. And the mission is that of supporting the various countries, different sectors in terms of decision making. So we have partners across the continent in South Africa, East Africa, West and North Africa. And we are using the Open Data Cube technology, and we borrow these from the Digital Earth Australia, where they have made quite some progress, and some of our services have been informed by that close collaboration. However, in Africa, we are working with partners who've been very instrumental in validating some of these continental services. So the program is providing the satellite data in analysis-ready format. So it means from the space agencies, we have the Landsat in the US, and also we have from the European Space Agency, we have currently Sentinel-1 and 2, and we're currently adding Sentinel-3 and 5P respectively. And we process this as analysis-ready format. So it means you move from those different levels, and you assist to access the platform to get some insights on some of your areas. And you can see from these continental examples, looking at coastlines, looking at crops, looking at different mountains, and even looking at the water extent. And we are streamlining our work to help the various sectors that on sustainable development goals, of course, and also we are looking at the different opportunities to collaborate with different sectors in terms of validating some of the work. So actually now the program has been moving from the data to actual insights, and working with the different partners in the continent, we've been able to see some of the use cases which I'll be able to show you. And we're looking at the various sustainable goals. We are looking at the different efforts by the different governments, and also we provide a GitHub repository for data sharing and collaboration. These continental services have been developed. The first one was the water observation from space, which we launched in the year 2020, and we've continued to develop other continental services, especially the GeoMAD, which are cloud-free mosaics, which are very useful for any kind of applications that you might have. So we are looking at that fit for purpose. Of course, working with different partners across the continent is quite a big value. So the water observation from space was the first product, and it shows water availability from space. I'll be able to show you a demo of the platform and see how we could get some insights. So we present over 35 years of data, which is very huge for your kind of applications that we are looking at. So we are looking at different wetlands. We're looking at those flooding events. We're also looking at the droughts and how they have transformed some of our wetlands. In the food security space, we worked with partners across the continent to validate one of the first level continental service. And here we are providing insights on the probability of cropping, and it has been quite an instrumental service as well. In the coastline, this was a game changer service, and we are looking at the coast and marine, providing over 24 years of data, showing you the insights, hotspots, rates of change. This is quite useful in the area of coast and marine. So some of these examples you can see, getting the dynamics of the coastlines, looking at the changes, just example of 2 countries. And this coastline service covers 38 countries in the continent. The water body service has been quite an important service. We are looking at just building on the water observation from space, but now getting those individual water bodies. Some of them, as we've looked through the continent, we've seen some of them have dried over time, but it was also very useful to see the exact periods, the months, etc., so that countries can work on their water management strategies. So our theme, that one of fitting into the climate resilience, we are saying that we're developing some insights on the same. And also we're developing some notebooks which are in the sandbox to help you in addressing some of these uh, areas. So we are moving from space to village, and also we are working closely with the different innovators to help them also empower them in the different solutions that they might come up with. So one of the use case we had in the program was a story on Earth observation for conservation. And in this particular context, we had Lake Baringo in Kenya, where we experienced some flooding. And this was a phenomenon towards the years of 2018 and 19, as that particular example shows you. There was a community in Samburu who had relocated the giraffes in the island here, Olelokwe, and over 50 years, they realized there were quite some worrying trends for the giraffe because they needed a safe sanctuary because of the flooding and diminishing natural resources and what they could feed on. So they had to work closely with the Kenya Wildlife Service and the Northland Rangeland Trust, where they were reformed to a safe sanctuary. So it's more of a collaborative, working closely with the conservation and providing those insights from space. Other use case we had was in the Kovango, specifically Lake Ngami in Botswana, which from Dr. Kileboke Mfundisi, she was able to give us some insights about the drying trends and how this has happened over time, and how the drought has really affected, especially the wildlife and the communities who live in north of Botswana. And this was quite a game changer use case. In Southern Africa, we are working closely with the coastlines, the SEON, this South Africa Biodiversity Network, and they were able to use our flat space platform so that they could provide some insights on the coast. And this one was quite very good game changer, looking at the flood in KZN. And this is a KwaZulu-Natal, and specifically a particular area where we're looking at the different coastlines. You could actually see the trends over time. In West Africa, we work closely with Big Data Ghana, and they were able to use some of the data sets in our platform to inform their in agriculture and food security project. And he's been able to do some work. This is called Henry Bafo, and closely to the youth mappers and African women in GIS who've been able to support some of the technical challenges, and some of them have been able to move from their different levels to actually workspace, different areas. They're working at different places. And in the Africa Women in GIS, we had Jokotola and Sinatemba, Nigeria and South Africa, respectively. And this year we are running another Africa Women GIS challenge as well. Access to the platform Digital Africa is we have through the Digital Africa map, and also we have the sandbox with the Jupyter notebook. We also have access through other web map services, and also we have a learning platform, Digital Africa learning platform, which is self-paced. So in the platform, in our website, digitalafrica.org, you're able to see the various areas, the platform, the focus areas, the learning and insights, and more specifically to this will be the map. We'll be able to show you a demo of the same. So this is the map site, which is a web-based interaction, either in your mobile or rather tablet. And just to take you through the particular demo, in the platform, you'll be able to see the Digital Africa map, the sandbox, the notebook, also Africa Geoportal, and also the user guide, and also the continental services that I've introduced earlier on, as well as the analysis ready data. So in the Digital Africa map, you can be able to move into, for an example, just starting randomly from somewhere, exploring the data, the continental services, even looking at the external data sets that we host. We are looking at the satellite images, the mosaics, and also data on urban data. So on the satellite images, we have the Sentinel-2, which uploaded every 5 days. This is in analysis ready format. So when you zoom into an area, for example, Nairobi, we're able to filter by location, and you can be able to get the data sets available for this particular region. So every 5 days, we'll expect an image. And also when you're not able to see the image because of the cloud cover, you can navigate between different dates and get a closer, better observation. And it's because of this now, like an example of an image of last month, 26th July, over Nairobi, was a little bit okay. It was a little bit cloud free when the image was captured, just showing you around the city and the national park there. And from there, you can be able to change the opacity, the background, just seeing the other base map, and also just navigating to see some of the wetlands, the eastern side of the city, and the growing suburbs in Machakos and Syokimau. And also just going through around the area around the UNEP, for example, and the forest and also other areas. You can also be able to change between the dates. We have from 2017. We could have an image of that time. Visually, you could see some changes, lesser building than what you could see in the other one. You can also do a comparison, which is very good to get you into giving us some insights into the images. And from there, you can be able to change the other image on the other side to give you that visual comparison of what you might be looking at. You could be looking at some trends, be looking at the change of the vegetation, the change of the housing or the buildings at the different times. So around January, we expect some cloud-free, at least some better visual data. So you could see quite some differences visually. So looking at an example of Karura Forest, where there's been some restoration efforts, you could see what is happening, and also around the northwest of the city of Nairobi, the suburbs, where there has been change from vegetation to built-up areas, and quite an interesting phenomenon moving close also to the outskirts of the city, where there's been quite a change. Also looking at the other side of eastern side of the city of Nairobi, especially in the area of Ruai and Syokimau, a change in dynamics, especially with the different droughts which were experienced in the year 2017 and quite heavy rains observed 2024, which observed also in the earlier 2025. So your area of choice will be informed by the area you're looking at. You're looking at different applications from agriculture, urban water resource, etc., etc. Then also changing the different dates. So mostly the map interface is more of explanatory, which is very nice because you're able to, be able to make some decisions on where your program is going or your research and some other data sets that you wish to add. So for example, it's very easy. You can just remove and add again, how seamless it is, changing from different data sets, also changing from other products that we have, looking at the vegetation, also looking also at the other services that are there. I'm also looking at the continental services, especially the cloud-free mosaics, the geomedian, which are very key because we've done a summary for each year to get a cloud-free mosaic. So this one now we can do a comparison from what we had in 2017. And this you can actually do for the whole continent because then it gives you an idea of some of the areas that you're looking at. You're looking at change in the cities. You're looking at changes, vegetation, where different cities are growing. We are looking at different, policies. The government has done some policies, or also the rural-urban migration and how it's taking an effect on the different sectors, different areas. So just moving into an area maybe of conservation, we could go to the example of Lake Baringo, which is the one we shared earlier. So here we have the island in the middle of the lakeway, but also you can just see when I drag from different times, I can see the changes in the extent of the lake. And this one visually from the Sentinel-2 images, we're able to see quite some change somewhere. But then we're able to get more evidence if we add the data on the water observation from space, which has been developed using Landsat 30 meters. So when you add annual water summary, it gives you the whole extent since the 1980s. And we're able to change the legend to something which is a little bit visually, you can do some comparison. So the blue areas have remained blue water over time. And we can also do the annual water summaries so that we can get an idea which are the years which we had quite some changes. So based on what has been reported, and also the power of journalism is to see some of these key dates and what happened. So going to the year 2017 thereof, we can be able to see how it was by then, recovering from some drought. And you could see the extent previously. And now going towards 2018, quite some rains were received. And 2019 respectively, quite some flooding events were mentioned. And the year 2020, it was actually even greater, seeing those trends over time. And also the small lake below is called Lake 94, which sometimes when they say excess water, they seem like they are merging. So that's the effect of the flooding observed from space. And also, as we discussed in the recent documentary, there's been a trend that the environs around Lake Baringo have been advised to move because of the changing levels of the lake, and it will affect schools, etc., etc. So you can be able to share the link to these, doing more comparison, different dates, saying what is the trend in a different date, for example, 2014, and the other one is a different date. Then you can just see visually how this one has been changing over time. Quite visually, you can see quite a lot has changed over time. So this is quite a great platform for us, and also giving us the information on some of the areas. So I could go to the surface water body, which is an improvement to the water body service. But now when you click on it, it gives you the graph or the trends, generally drying times, and over time, we've had a steady increase of the lake. So this has been in the reports about the raising levels in the Rift Valley, reported around the year 2014, 2015. The trends have been going up. So those will be something that you could capture for any water body in the continent, any country. So most of the work, like in the sandbox now, you're able to log in with the password you've been given, or if in case you've forgotten, you could do a reset, and you're able to sign in the platform. And once you sign in, you're able to scroll to the bottom and choose one of the instances that you choose to use. And from there, you're able to make some access to the platform. So on this other side, I could also do another example of a demo, possibly on the coastline service. So in this case, looking at the coast of Kenya, for example, I could add a data on the coastline service as an example. And with this, be able to see over 24 years of data showing the change of the coastline. Some of the areas in red could be areas which have changed more than 5 meters. So this was just a small interaction in the sandbox. Then going back to this South Africa map example, which is very key as we are trying to onboard everybody. So you're able to change the map in the background as well. The base map, where we've worked closely with Esri to use some of the base maps. And when you zoom in, you can see visually those areas in red, areas which have really had changes, strong changes in the coastline, looking over 3 meters, 5 meters, and others have been even greater. Some of them would be mostly the change in the coast estuary, as well as more change in the coastline, and especially the areas of Mombasa, Malindi, and Batam. So the scenario will be different if I was looking at the whole continent, because then we've seen the continental level at the scale, the trends around West Africa and Nigeria, around Namibia, and also the coast of Mozambique. In North Africa, also, we've seen some of these changes, and we'll be explaining that in the respective sessions in the French and Portuguese, just making it a little bit dynamic for those ones who are able to attend either of the sessions. So this is the data on the mangroves. So this is from the Global Mangrove Watch. They provide the data sets from 1996, which is very key because it gives us a background on the mangroves collected by data sets, which was done by the team at NASA. And over time, they've been building this database every 10 years. For us, it's very key because around Mombasa, we can see where we have mangroves. Some of these are efforts by the local community to replant the mangroves because the mangroves are used for different economic activities. So when the communities are empowered, at least they're able to conserve the mangroves, which means that their coastal areas will be a little bit more resilient as it controls the waves of the coast. So those are the mangroves in the region. And also we could add another data set, etc., etc. So this is just the dynamics of what we have from the base map to the different areas that we could look at. I was trying to look at another example of agriculture and the cropland service, so that at least we are able to see from these different services. So this is the cropland, and now we can go to the probability of cropping, which will now show you the exact probable areas that we have some cropping data. And this one, you can use it to train your machine learning. So the percentage is towards 100 yellow. You could have exact probability of areas. So with this would be where you would be actually moving into an area that you are aware about the areas. So other ways of accessing the Digital Africa, we have the Metadata Explorer, and also we have the web map services. And also we have access in the Africa Geoportal. And also we have access through the direct access, where the team is working on providing some methodologies on the same. In the sandbox, which is our area, at least for the purposes of this interaction, to give you examples of the different applications from agriculture, water, urban, land, and coast and marine. Also, we have this repository on the SDGs, Sustainable Development Goals, which we try to provide an indication on where you can use Earth observation for Sustainable Development Goals reporting. And now going to the sandbox and now giving you the particular demo on the sandbox. So we have, when you log in, we have the thematic area where it gives you those specific notebooks that you could explore for your different areas. You're looking at land cover, agriculture, machine learning, meteorology, or satellite imagery. You're also looking at different applications from water and also looking at urban. In the real world example is where we have most of the notebooks that when you explore, you get quite some ideas for your work. You'll be interested in looking at some of them, just getting an idea. And where you don't get the exact notebook, you can actually now do your custom development, where, for example, when we worked with the International Water Management Institute program, they were looking at different applications in water. And there they had to develop the different notebooks. One of them was looking at rainwater in a water basin, etc., etc. So when those notebooks are not available in this area, you can actually do a custom development of the same. Just when we do an example of one of the notebooks, you'll be able to see how easy it is to run most of these. And from most of these, since we provide the recording, we'll be able to do a follow-up and see how it works for your certain areas. And we'll also provide the slides to this presentation so that at least you're able to follow at your own pace. So most of the learning is through the notebooks, Jupyter notebooks in Python. No need of cramming those algorithms, just giving you an environment where you can just go and run them. And from that, you can always do your custom development, or from these notebooks, you can actually come up with some results which you just insert directly into your project. So it's just a workflow to save some of your work, but ideally you'll be the one with the most of the insights. So looking at the learning platform, we have, when it opens, these the self-paced courses, Introduction to Sandbox, Map Guide, and also the weekly live sessions that we have in English and French. And when you go to the particular courses, you will see Discover New, and you'll have access to all these courses, and you can enroll at any time. They are all self-paced, and you're able to monitor the progress. This is an example to the introduction to the sandbox, quite giving you some informative, and you can be able to monitor your progress, and also you can request for a certificate, and all the dates are just at your own pace. So this also gives you that flexibility in case you wanted to learn more on the platform, other applications, for example, and other modules we developed with our partner. The user guide is also very useful because it gives you an explanation of some of the notebooks. For example, the WebGIS, we have examples how you can access the datasets in Digital Africa in your GIS software, QGIS or ArcGIS Pro. You're able to call through the web map service, web covering service. We also have the direct access through Amazon Web Services, and you could link to this particular datasets either in Google Colab or AWS SageMaker. We have also ODC Stack, which allows you to access some of these datasets, etc., etc. Also, in the Metadata Explorer, it gives you more information about the datasets, the ones available, the ones captured, and this is very key, especially for your metadata. Also, there's more information also on the Digital Africa map, including the step-by-step definition, and also more information about the continental services, and also on the analysis side of the sandbox, giving you exact details of those particular notebooks that you will have seen in the platform. So again, in the platform, Digital Africa map and the sandbox, then in the insights, this is finally where at least you can share some of your work. And there we're able to capture some of your stories, including how you're using the platform. And in the insights, you could click by country or by name, and you can see some of the examples of some of the work and some of the champions who are really key using the platform, especially next time I know it will be you. And also just guiding you to the different areas, thematic areas, etc., etc. So with this, at least this is a very good onboarding. The examples in agriculture and food security, I'll be able to share at least one or two. So this is typically from the sandbox, what we're able to see. Some of the examples, crop health, phenology. So you could generate at country level or at farm level, the optical and radar. So at farm level, we have this particular example of a notebook, which will show you how to do step-by-step and digitizing plots to get more information. So in this particular example, running it, we just need our array of extents. We are using the Sentinel-2 at 10 meters based on the question which was asked in the chat, just having the basic information about the imagery as well. So I'm looking at a date 2024, and those are the images loaded over big stacks of imagery, an example of oil funds settlements in South Africa. So you could digitize small plots and get some feedback about the phenology of that particular farm in the period from different dates. Then you could add another plot just to do comparison. This will be the case of a farmer who has different plots and they wish to know how the productivity has been from space. So the curve will be different based on the planting season and our seasons that we have, for example, in South Africa. Currently, the winter periods from May, June, July, August, and the summer, they are off into December, going on to the early the year, which will be different from different areas north of the equator. So this will also depend on the farming, either it's irrigation or rain-fed, or in this case, we have a lot of the farming around the river. So this very common in Southern Africa. We have crop cycles and also some parts of North Africa, especially in Egypt, where irrigation is done in central areas, and you can monitor the rains from time, and you can plant different crops, different seasons. So this is just an example of one. And also, if you change, you can change the dates, the years. You could even have even the year of 2025, for example, today is 12, I guess. So we are saying these imageries of Sentinel-2 every 5 days. So that could give you an indication of how you choose to look at different examples. So typically when you do the run and restart of your kernel, you could work at different examples of areas. This is how seemingly easy it is. The images are loaded for you, and you'll have this particular dialogue as will help you to get more information on the crop health. Then also we have the optical phenology, where with the same extents, you could run the same and get more information about the start of the season or the end of the season. So in my phenology optical notebook, I'll be able to add the respective coordinates here. So just knowing your lat and longitude, which are very key also, because the extents, for example, it could be a mobile farmer, you're doing farm from your city, and you're monitoring what people are doing in the ground. So you could actually change the different dates. So this one, you just restart and run the cells, and you'll be able to compute this respective phenology for a particular year. So this is my oil funds looking at the A times of 2025, the dates selected, and also sometimes depending on internet connectivity, you might have those freezing screens, but always when you refresh, you get a good plot, and your work will be able to complete. At this time, I was trying to run many windows, and that's why I had this small freeze. But after some time, it's able to load back to where we were. So the phenology will be loaded differently based on what is planted and the different seasons. So those are some of the information that you could have noted in your previous research or in your work that you actually do. So we are looking at people interested in crop insurance, looking at people just interested in the phenology, different dates, different programs, especially where they do crop rotation. And in your digital Africa map, immensely, you can just change between those dates. This is the area in oil funds, South Africa. Then I'll add the data on crop phenology app. So you could also add a satellite imagery and just get some images in the background. It's a simple red, green, blue imagery. You could also change the vegetation index on the fly, or have come and look at the false composite, giving you an indication of the greenness from space. You could also change the dates between different times, etc., etc. So adding in the crop phenology, so just giving you the idea that you could be running different data sets, especially the yellow, bright yellow, to give you information about the crop area. Then on the phenology, which was running in the background, it was just giving me an information about what was planted in the whole area and possibly how the phenology was. So here we are using the normalized difference vegetation index. That's as an example. And then finally, you'll be able to see your image, the area of interest, for example. And you might choose also to choose a smaller area, looking at the images loaded over 1 year. And you could also change the different bands, the different times as well. So this is the crop phenology over time, looking at the vegetation index and looking at the start and the end of the seasons, and just giving you an indication of how much information you can get. So you'll be looking at generally from this, to be able to predict phenology of 2 crops or 3, but basically the seasons where there's at least harvesting and end of seasons based on what was planted, which could be different for different seasons and different plants that were grown. So the crop health, quite informative one, as you've seen, just as a summary. So this could be a different result for a different area that we are looking at. So this is just the dynamics of this presentation. So example, this was an area in northern Ghana called Sisala, and we're looking at some different crops where we noted the start of a season in April, May, and also in the summer period and towards the rainy period in August, and where they could be harvesting different dates. So you could also have the same example in optical. This is the Sentinel-2 itself at 10 meters. Then we have radar. This means Sentinel-1 from the European Space Agency, which is not affected by cloud cover. In the forecasted vegetation condition is an example of some work which was done by one of our colleagues. And here we've been trying to see if you could forecast vegetation for the next 1 or 2 months. It's quite showing some interesting results. And also we could compute vegetation anomalies at country level. So this is an example of South Africa in this context. So you could change different months or different dates. Looking at the change of vegetation, we could pick out areas of deforestation and also inform some of the government restoration efforts which have been put in place. Then we are able to couple with the vegetation index with animation. This is an example of some croplands in Madagascar, for example. So you as is to know the extents of the area, the lat long, and looking at this over time, you can be able to compare vegetation and the rainfall data. Burnt area mapping has been of interest based on the areas that are picked in terms of case studies. So we have an example of West Maprokusi Municipal in Ghana, for example. So it's just knowing the latitude and longitude of the area and the exact dates of the fire event. We also have the same with an example of a fire event which was reported in Southern Africa in Cape, this area around St. George. So we're able to compare different dates. This is the year 2018 and the dates where the fire was reported. So we could see the images before and after the fire event. So also we have the fractional cover using the Landsat data, which will be very useful to give you an example of cropping events and the change of the dynamics over time. We have examples in the water and risk flooding. In this case, these are some of the notebooks that we introduced and taking you to examples, the Lake Baringo one, which we were able to witness, and those particular dates mentioned from the years mentioned. And this other one is a small lake, Lake Ulbolosat, which has picked from the images from 84. The extents were a little bit bigger, but over time, it has been really decreasing over time. And it was reported in the dailies that there was an issue of climate change. So we have some wetlands and lakes which are shrinking at the same time, and others which will be in the same time increasing. So we have the case of Lake Bosumtwi in Ghana, for example. We are able to use to get the water index and, for example, the case of Sentinel-2. And based on the dates I was giving you from the early January of 2017, we're able to go through different dates and see where the lake has been over time. And from this, we can be able to show you an example of the water extent in your sandbox. So here we are looking at changing the latitude and longitude. And in this case, I wish to show Thikutuskulaf Dam in Cape Town, where it was reported drought the year of 2016, 2017, 2018. And you can see from the different dates, the drying in the 2017 and potentially the highest drought, and then recovering thereafter in the year 2019, 2020. So you could present such an animation in your project or in some of your work, which will be very key to the stakeholders that even getting a high level interaction with some of the policymakers to inform them these are the trends and we need to get some action. For example, integrated water management, and also alternative ways of storing our wet water in different dams so that when we have drought, we could have alternatives that we could explore, especially when now we are working with different partners and different stakeholders and different projects. So also from this example, we could look at water quality from space, very key with Sentinel-2. And there's that particular index with the chlorophyll index, gives you an idea from the colors we see from the blue to the red. And red would show some areas of quite not good water quality. And also it's also tied to low volumes of water in some of these dams, then the quality will not be very good as well. Looking at long water animations, this has been built on the water body service and it's given us some interesting insights as well. And also recently we are working with the Department of Water and Sanitation in South Africa to show some changes in some of the dams. And we'll be having a session tomorrow on the live sessions to show you the change in the dams, etc., as an example. Then in Nigeria, we have our collaboration with Afrigist in Nigeria. It's a training institution which works in the member states in Nigeria, Benin, and Togo. And in respectively Nigeria, we had a use case where we are using our images Sentinel-1 and 2 and the European Space Agency land cover data to show some insights of flooding areas. And from this, we're able to see the flooding around river Benin and the exact areas and also the particular state in Kogi State and how the trends every year have becoming worse, where especially in the year of 2022 and 2021, 2022. Then from this example, we have also just looking on our end, what we had in East Africa, we have an example of flooding events in Kenya, where we're able to show some of the examples with our partner Regional Center for Mapping in East Africa, showing insights and areas of flooding. And also we have a collaboration with the International Water Management Institute, where we've been looking at different applications in these 5 countries, Ethiopia, Ghana, Burkina Faso, and Zambia. And we'll be adding other countries based on the work plan. And here we have a series of people from different institutions who have been trained on the Digital Water Innovations Program. And also they've been able to use Digital Africa in some of the use cases that they're looking at, including water management. Our collaboration with Esri has really grown, especially some of our tools are available now in Africa Job Portal. And this was just an example of some of the engagements and we're able to showcase. In area of urban and applications, we have the example of looking at urban change, urban index, looking at the world settlement footprint data, etc. So this is an example of change in the urban area. This is an example of Windhoek in Namibia, just trying to be dynamic as possible. And here we are using the Sentinel-2 geomedians, which are cloud-free. Then you're able to compare the extents of 2 years. So initially, most of the urban change, we've been using the normalized build-up index. But over time, we've seen the other indices such as NC and others, which have been used by other programs to be very useful for different areas. Then for your urban areas, we're able to compare with the results of Sentinel-1. So this is a case of Nairobi, city of Nairobi, looking at the areas which have really grown. And the same, we could look at them in using Sentinel-1 example. So this is the example of the change in urban extent in your notebook, in your real world example. We're able to put in the coordinates or area of interest, just looking at one of the cities. So here I was able to add the coordinates of Johannesburg, for example, and looking at the extents of the city of Johannesburg and its suburbs, we're able to load now the geomedian, which is the cloud-free mosaics from Digital Africa, now looking at Sentinel-2, and we're able to compare visually from what we see over like 4 or 5 years, what we are seeing. And using this particular index NC as a build-up of the index, it's able to capture the built-up areas and respectively showing you the extent over time, then applying some certain thresholds. We're able to capture now the city itself, as you can see in yellow, and also comparing the change in the extents, different years, running some certain algorithms. And also you might choose to use also a shapefile of your choice to capture the extents. So this will be just one of the examples of the urban change that we're able to capture from the platform. So every area will have a different story. As we know, the cities have evolved over time, and over time our governments have put in some place to put in some measures, including designated some urban zone, etc. So this is the other example of urban index comparison. Here we showcase the city of Dakar, Senegal, because then the city around it, we have water areas. So just picking in the built-up area around the city will be quite complex. But this one normally does the trick, and it normally borrows some data from the global human settlements data. We also have other examples of the world settlement footprint. In this case, an example of Johannesburg, for example, showing you the extents over time. What was the urban area in 2015? Or what was the urban area in 2019? And this is data borrowed from the European Space Agency program, where they were building some data sets on Sentinel-1 and 2. And from these, they were able to add the world settlement evolution data, capturing Landsat data. In the context of now urban area and urban tree estimation, it has been an area of growing interest for most of our countries. And this Digital Africa borrows from the partnership with Sahel and West Africa Club, who have data sets on Africa job policy. In the area of marine and coast, we have an example of showing you the change in mangroves just from what we captured in the example, the Digital Africa map, showing you areas which have been mangroved and areas where the communities have generally slowly over time done some replanting. Also, we have some case of small mangroves, an area in Umgeni in South Africa, just showing you some extent of some areas. And basically, this area, we've really lost a lot of mangroves, and every year we find ourselves quite vulnerable, especially the two cyclone events that might happen early in the year and the end of the year, as we observed over time. And from this, now I can be able to show you how to run this particular notebook. The mangrove analysis, you restart and run the kernel, and it will be able to make some decisions on what to classify as mangrove. And from that, it will borrow from the global mangrove data set as a reference now to actually classify for you the mangrove area. So this is around Mida Creek in Kenya, in Watamu, West Africa. And from there, we're able to put in the coordinates of the area and add the data sets and slowly clip to our area of interest and load the mangrove dataset watch data to just depict the mangrove areas. And from that, couple it with the model tidal heights, just to get more information. And looking at some of these datasets are quite big, and everything is done for you in the cloud. And finally, you have at least a visualization of the area, the extents in terms of vegetation index, and the reclassification of the mangroves respectively. And finally, just getting now visual information about our areas of extent, the mangroves over time, and the change in mangroves, the dates, and also comparing to previous dates, looking at the areas which have been replanted and areas where they have lost mangroves. And also comparing this to previous data sets from 1996, which will give you over 30 years plus data. This is quite useful historical information, because from here, what was shared was that they lost a lot of mangroves initially. Then they had programs by the government for the restoration of mangroves over time, and we've been seeing quite some positive results. So some of these interventions sometimes might take some few years, but in such platforms can help us to track what could have happened. So in your Digital Africa map, we could zoom into the area, looking at the mangroves, so that we have at least a complete understanding of the different applications. And from there, you could make a decision on which application or which platform you will use for your Earth Africa observation challenge. So looking at the mangrove areas, as you can see around East Africa, moving to areas around Lamu, Watamu, Lamu, for example, you could see the mangrove areas. Then we could also see what was the mangroves in those earlier years. You can see the trends. So you could also go to the 1996 and see generally maybe there were more, but over time there might have been changes, difference based on the different programs and land cover, and also different programs which were being run, and generally just change in the climate change, just showing you some of the small areas that you would have noted visually from space. So this is quite some informative information for us, just to see how to look at the mangroves in a different perspective from the global data and from what you could generate from your end, and also from other land cover classifications that you will be able to run. So at least by the end of the sessions, we are really empowered from the mangroves to the change in the coastline. So looking at over 24 years of data, we can see some of the hotspot areas, and also just taking you through very fast, we can look at the coastal erosion. So these are the different application areas in the coastal erosion now notebook. We could be able now to put in the coordinates of our area. For example, Mombasa in East Africa, and then Now the notebook has been improved. It adds more data sets. Initially was Landsat, now adding Sentinel-2 to the decision making of the coastal erosion to train it a little bit best. So those are the extents, so the lat long, and changing the different dates. So at least working with a date of our choice and the area of interest, just back on the Digital Africa map example, and also go into your Google Maps in case you do some reference data to see what is there. And then now going to some of the results that we're getting just around the mainland area, and also running it to some querying, and it will be able to make a decision whether to use Sentinel-2 or 1. And from there, you can see quite heavy data sets being used. And from that, we're able to come up with some interesting results as we go through the various examples. So this is quite informative. You could do it for any coastal city. As you mentioned, the coastline covers 38 countries. And of course, you know the country with the longest coastline. So this will be some of your results, just showing you the exact areas. And this is quite informative for you as you present in your work. Just looking at the change in the coastline over time. And here we're just looking at some 4 years or 6+ years. And this one runs up to the year 2000, for example. So this is quite useful to track some of the areas and hotspot areas, and even seeing the rate of the coastal erosion. And also we can be able to see in the final end here, the rate of change of the coastline, and with the red showing you some white areas which have seen hotspot areas, and the blue relatively okay areas. So this can be very useful, especially when you have projects and some of the coastal management plans, which could affect the fishing and other economic activities around the area. So from this one now, we could look at country level coastal scale rate change. Just looking at the example of Kenya, for example, and we can be able to change the extent of the area. So country level information, and now picking in the coastline data over time. So you could generate for any country. And with this one, it's because it's able to give you now the specific municipalities or areas that are affected by the coastal erosion. So we look at the coastline, which has been mapped. And also now we are going to look at the change statistics and areas which have been affected, especially within the administrative data of the area. So loading these counties in Kenya, we could now narrow down to the ones which are covered by the coast. And we'll be able to see quite some number, at least 6. And from that, the notebook will give you a decision that we've added also, for example, Garissa. It's because of the Tana River, which has experienced some flooding. So that now when you do a further refinement, now we'll be able now to narrow down to only the 5 counties, Lamu, Kwale, Tana River. And you'll see now the areas affected, so that now we specifically focus on the coastal counties. These are the administrative units, Lamu and etc. And you see Lamu is the most affected in terms of coastal retraction and also advancing of the coast over time. So these are quite useful statistics you can generate for any country, just as an assessment, and coupled with some other data available in the Amazon Web Services. We'd add data sets on the graded population, and we'll be able to come up with some information about the population of the area and how vulnerable and exposed people are. And also we could look at the elevation of the area, which is maybe less than 5 meters, where you could really have people who are really affected. So this will be ultimately the Lamu area, which has a series of islands, and they are quite low level islands in terms of elevation. So just at the summary, we'll see the exposure hotspot areas around Lamu area, and we'll be able to see actually the exact location and localities. So this will be around, yeah, see around Faza and also Dodori. So there's some specific areas that you could be able to see, and this one, if you captured some of the reports, would have been areas which have really been affected. So these will be areas which are low level and low, less than 5 meters in terms of elevation. The population is quite vulnerable. So this is quite a useful service as well. And also looking at the coastline dashboard that has been developed courtesy of our partners, Esri. And also now looking at the cross-cutting themes where we have land degradation. We also have a course on the same, showing you land cover, forest monitoring, burn area, and desertification. We can generate land cover data for the country level and look at the general land cover trends and look at the change of the vegetation and see areas which might need attention. So this looking at the country level, like Kenya, for example, we can see the trends over time and areas which have been really affected over time in terms of change in vegetation and areas which have remained stable and areas which might vulnerable to desertification. So this is an example of Ghana, and you can see from the trends and most parts of northern Ghana are quite vulnerable to drought. And also we're able to have this combined drought index, which has been developed, showing you an example. And finally, showing you examples of surface mining. Is already a notebook of the same. Just an example of change in mining areas. It's an example of Aparama forest in Ghana. And finally, just giving you more information about some of our events we've had and specific thematic areas that could give you more information. And also just looking at the insights of some of our champions and also the learning platform, which I was able to show you earlier on. So on the learning platform on the website, you'll be able to see the introduction to the sandbox. And as you saw, I was able to give you a breakdown of some of the courses, which are self-paced, which will encourage you to have a look as we end this particular session today. Looking at the user guide as well, self-paced, giving you more information on the tutorials, etc., etc., and looking at how to use the sandbox, the different notebooks. Some of the notebooks we looked at, example, the crop health, you could be able to click and see more information about those particular tools, and also giving you an idea also how to further develop some of your notebooks to do some certain tasks that you could be having. The learning platform, self-paced with your password, and you're able to sign in. And you're able to view the different courses, including those ones you've completed, and you'll be able to get a certificate of completion, the introduction to sandbox, agriculture, food security, etc., over 18 courses, and also looking at different courses and some that you could explore. And once you complete, this will be quite an achievement also for you yourself and also for learning different platforms and new platforms as we're in an era of information and learning. Looking at the course coordinators, the courses are already self-paced. You can enroll at any time. Looking at the different sessions, modules, and finally, you'll be able to see your certificate of completion. Quite useful information. So with this, I think you'll be able to get more insights into the platform and also get more extra sessions and see how you could work with the platform for your project. You could request a certificate. And finally, looking at some of the areas that the courses themselves, and also looking at further information like the user guide, and also looking at the resources that we have in terms of support, technical support, or use case. Are you able to submit some of these forms and we'll get a response respectively? And the insights, this is where most of you will come where you'll be able to share some of your stories, and Digital Africa will be able to feature some of your work and celebrate your success. Finally, looking at some of the examples, you could narrow to any country, and it will give you some information about what we have currently or something that we are working towards in the whole continent. So this is quite a good platform for us to be empowered, looking at the focus areas, which we'll be able to go through, and also extra resources on the YouTube, where this video will actually land shortly, and looking at some of the stories that we have. And finally, just as a summary, the resources are here, and the website is quite useful, and the platform access, etc., etc. So these are the links to the specific courses, and also connecting with us in the live sessions that we have in English and French, and a recognition of our partners, Helmsley Trust and the federal government and other partners. And also, as I pause here to the end, welcoming my colleague Joseph to give us some remarks